Question number 36. Three batteries in three identical resistors are connected in a circuit. Okay, identical. All of them are having the same resistance. The batteries have negligible internal resistance. What is the potential difference between point P and Q? Now let us write down this circuit. This circuit looks like this over here. Okay, so now it is like this. This is your 9.6 volt over here. This is your resistance R. Now coming back to this is your point P, and here you have a resistance R. Then you have a battery here. Then once again you have a battery here. So you know that the polarities over here. This is 8.4, this is 6.3, and you have a resistance like this, and this is your Q here. What did I do? I took this triangular part, made it a linear one. That's it. Which is because we are used to this linear one, so it becomes easier for us. Right now you see the batteries are opposing, so I can now simplify this circuit by writing upper branch remains the same 9.6, then a resistor. Lower branch you have R and R in series, so I can put this as 2R, and then I can take 8.4, 6.3, they are opposite polarities. So I can just substitute, I can just subtract them. 4 minus 3. So this is the higher terminology, right? I'll write like this. So 4 minus 3 is 1, 8 minus 6 is 2. So this will be 2.1 volt. And then I'll connect it over here. This is your Q, this is your point P. Now what does this lead to? Two batteries connected in parallel. So how do we solve this? The solution is E total divided by R total is equal to E1 by R1 plus E2 by R2. Okay. So what is E1? E1 is nothing but 9.6. 9.6. R1. What is R1? R1 here is R. I do not know what is R. I'll just write R. Plus E2 2.1. 2.1 divided by what is this resistance? 2R. 2R. And then ET. I'll write ET here. Divided by what is R total? R total means I'm going to remove the batteries and find out what is the effective resistance. When I remove the battery, what will happen? You will have one resistance like this, which is R, other resistance like this, which is 2R. Now these two are appearing to be parallel. What is the effective resistance between these two? Effective resistance would be 1 by RT is equal to 1 by R plus 1 by 2R, which should now be equal to, take 2R common, this should be 2 plus 1, this is 3 by 2R. Okay, R, I can now write R total is equal to 2R by 3, right? So I will write this as 2R by 3 over here. Okay, so in other words, I can now write E total divided by, okay, I'll take this 3ET, 3ET by 2R is equal to, now I'll take the LCM here, so this will be 2R. And this will be 9.6 into 2 will be equal to 2, 6 are 12, 1, 2, 9 is 18, 19.2 plus 2.1. Okay, so this 2R and this 2R goes away. So what do I get over here? I get the answer here as this is 3, 19 plus 2 is 21.3 is equal to 380. The E total, or your E total will now be equal to 21.3 divided by 3, which should be equal to how much? Which should be 7.1 volt, which is the right answer, 7.1 volt, and that is C.